Welcome back to the deep dive. Today we are getting into something that seems, almost ridiculously small, how we name variables in code.
It seems small.
Right. But we're going to show why it's actually this huge fault line between long term success and just total technical disaster.
It really is.
Our mission is to dissect this thing called the three character rule. We've got sources from cognitive science, from industry case studies, and we're going to show why clear names are really the foundation of software that lasts.
And to just set the stage, there's one surprising fact that changes everything. In software, code is read far, far more often than it's written.
Okay.
The data we looked at shows developers spend about 60% of their time just reading and understanding code, not writing new stuff.
60%. Wow.
Uh-huh.
That flips the whole idea of efficiency on its head, doesn't it?
Completely. Speed used to be about typing fast, writing terse code.
Sure.
But if 60% of your time is spent reading, efficiency is now all about speed of comprehension.
Right. Which brings us back to the rule.
Exactly. And that's why the sources all kind of converge on this one guideline.
Yeah.
Variable names should be at least 3 characters long. It's this perfect balance between, being brief and actually having some meaning.
Okay, let's start with the money, because the economic cost is where this argument gets. Well, it's pretty hard to ignore. You call this technical debt with compound interest? That sounds bad.
It is a terrifying loan.
Yeah.
And it's one I think most companies don't really grasp. They know maintenance is expensive. The number is something like 60 to 80% of a product's total lifetime cost,
60 to 80%. Wow.
but they don't get the compounding part.
So how does that interest how does it build up?
Okay, imagine you use a cryptic name. Let's say S for subtotal. The first mistake is tiny, a few seconds of confusion.
Right.
But now, every single time a developer, a teammate, someone new a year from now, sees that S, they have to pause. They have to stop, figure out what it means. That pause is the interest payment,
And you make that payment over and over again.
over and over.
Sure.
And you see it in the data. Projects with lots of what we're calling cryptic code, those 1 or 2 character names, their cost of change just shoots up exponentially. Those little pauses add up.
And you have to wonder, where did this habit even come from? Using single letters like I or X, it's everywhere.
Well, we have to give the old school engineers a pass.
Okay.
These habits were born from necessity,
Yeah.
from really severe memory constraints in early computers. When memory was measured in kilobytes, every single character mattered.
Sure.
You were trained to save every byte.
So it's a ghost of a hardware limit that just doesn't exist anymore.
Exactly. And that ghost clashes so violently with modern software, with these huge collaborative projects. We don't have memory limits anymore. We have cognitive limits.
Hmm.
And that's the immediate cost, that mental slowdown.
Yeah.
Every time you see a single A, you break your flow. You have to go on this little hunt for context, and that interrupts the real problem you're trying to solve.
So let's dive into that, past the financial drain and into the brain drain. How cryptic names literally overload your brain.
This is where it gets really fascinating, because programming slams right up against our built-in psychological limits. There are 2 key ideas here.
Okay.
First is what we've been calling cognitive friction, that mental effort. But the reason it happens is because of our working memory limitations.
Right.
Our brains can only hold and, juggle a few new pieces of information at once. The magic number is somewhere around 4 to 7 chunks of information.
4 to 7. That is not a lot when you're trying to debug a complex system.
It's critically low.
Yeah.
And here's how naming affects that. A good, meaningful name, like user profile.
Yeah.
Your brain processes that as one single chunk. It knows what it is, it files it away.
Got it.
But a cryptic name, like up or just you, that takes up one of your precious memory slots just to hold the mapping,
Yeah.
you have to actively remember, okay, in this function means user profile.
And that's one less slot you have for tracking the actual logic. You're forced to hold the glossary in your head while you're trying to solve the problem.
Exactly.
So let me just challenge this for a second. Are we saying never use a single letter? I mean, for I in range, right? That's a convention. Everyone knows what as is there.
That's a great point, and context definitely matters. If I is defined and used within, say, 3 lines, the cognitive cost is probably minimal.
Right.
But the rule is, for the other 95% of the code, the variables in the middle of a 50-line function, that's where the problem lies. And that's what brings us to the sweet spot,
The guideline.
the guideline. Cognitive science suggests that 3 characters is sort of the minimum you need to create a recognizable pattern that the brain can process instantly as a single chunk.
So we're not talking about writing out temporary user count every time.
No,
Oh.
no, not at all. We're talking about efficient, instantly understood abbreviations that hit that 3-character minimal.
Like IDX for index,
Perfect. Or XIR for user.
CFG for configuration.
Exactly. Or TMP for temporary, CNT for count.
These aren't random, they're logical. The second you see IDX, you know what it is. There's no pause.
And that's the difference. For INR forces you to stop. For IDX and IR is just seamless flow.
To see this in action, you found a great case study, the FISDES project.
Yeah, this is a Rust library for chip design, VLSI. I mean, this is a field where precision is everything. A nanometer matters. Ambiguity can literally cost millions of dollars.
So a place where clarity is not optional.
Not at all. And they did this huge refactoring effort based on the very rule. Let's just look at one line of code.
Okay.
Before the change, they had let A, point.new, XY,
Terse, fast to type. But what is A? What are X and Y?
completely ambiguous. And after the change, it became let PA, point.new, Xcord, Echord. See, that PT prefix instantly tells you it's a point object. And Xcord removes any doubt about what X is. It's not a scaling factor. It's not an index. It's a coordinate.
And that clarity is worth so much debugging time.
Hours. And this wasn't just aesthetic. The sources showed it had these huge measurable benefits across the whole project.
But like what?
Well, the most immediate one was that their test became self-documenting. When you see a test with variables named dat and vectransform, you understand the test's intent before you even read the final assertion.
That's huge, because test maintenance can be a nightmare.
It is. Then you get readable function signatures. A parameter changes from just T to alpha or F to func. The code explains itself. You don't have to jump to the definition to figure out what to pass in.
And finally, it created project-wide consistency.
Yes. They adopted prefixes, PC for points, vec for vectors, polygon for polygons. It becomes a shared language. And that dramatically cuts down the time it takes for a new developer to get up to speed.
And it's important to stress this isn't just for Rust or for chip design. The sources showed this scaling across completely different industries.
Yeah, the data was really compelling. In financial trading, where clarity is critical for risk, they saw a 40% faster onboarding and a 25% drop in bugs during maintenance.
25% is a massive reduction in risk.
Huge. In healthcare, it led to 30% more efficient code reviews because reviewers could focus on the logic, not on deciphering abbreviations.
And in e-commerce,
35% improvement in new developer onboarding time. All that time saved trying to figure out ambiguous code went straight into building features.
So we have to address the number one objection, the one that's been around forever. But it takes too long to type.
And that argument is just, it's obsolete. Economically, it makes no sense anymore. The cost of a few extra keystrokes is nothing compared to the cost of that 60% reading time.
Especially with modern tools.
Exactly. You have auto-completion, you type cust, and your IDE just fills in customer profile. The keystroke cost is basically identical.
And you don't have that old fear of what if I need to rename this later?
Right. Safe refactoring tools handle that. You can rename a variable across the entire code base with one click, confidently.
And you can enforce it automatically with linters.
You can. The tools are there. The cost of typing is gone. But the cost of ambiguity, that's higher than ever.
So for anyone listening who wants to actually do this, we've pulled a pretty clear 3-part playbook from the sources. Step 1, establish team standards. You need a document. Define your common abbreviations like SR, CFG, and also your domain-specific ones. TXN for transaction, PAT for patient.
And second, and this is key, use meaningful abbreviations. The abbreviation has to logically connect to the full word. Cust from customer is good. CD is not. If it needs an explanation, it's failed the test.
And the final piece, consistency above all. An imperfect but consistent standard is so much better than chaos. If the team agrees on us, then use us everywhere.
And while you're doing this, there are 2 big pitfalls to avoid. First is over-abbreviation. Don't get so clever that the meaning gets lost again.
Right.
And the second thing, the big question you should always be asking yourself is, will a new developer understand this in 6 months without having to ask me?
Because if the answer is no,
then you're just writing a bill that your future self or your future team is going to have to pay.
So that really brings us to the end of this deep dive. The 3-character minimum, it's not just a style rule, it's a deep psychological and economic strategy. It's about cutting cognitive friction and slashing technical debt.
And it all comes back to that one truth we found everywhere. The best variable names are the ones that need no explanation.
Absolutely. And the whole industry is moving this way. We see AI-assisted naming, better IDEs. So here's a final thought for you to chew on. If we solve the basic problem of readability, if we clear away all this low-level friction, what entirely new levels of complexity, what bigger, more interesting problems will that clarity allow us to solve next?
Hmm.
You don't have to refactor your whole code base tomorrow. Just start small. In your next code review, find one ambiguous variable, change it. Write code your future self will actually thank you for.